Hi everyone. Okay, in this video, we're going to talk about estimating mu. And we all know by now mu is the population mean. Again, to write the confidence interval, we write x bar minus e and mu x bar plus e. Or we can say mu is a number between x bar minus e and x bar plus e. Like in the last videos, I said e is the margin of error and x bar is the sample mean, which is the point estimate for mu. Now here we have to be very careful because to find the margin of error, we don't have one formula only. We have a couple of them. So the first one says E equals to z sub alpha over 2 times sigma over square root of n. If sigma is known, or you can say n is greater than or equal to 30. The second one is t sub alpha over 2 times s over square root of n if sigma is unknown or n is less than 30. Now let me explain something. Well, first of all, in this case, sigma is the population standard deviation and s is the sample standard deviation. So to estimate, we don't always use the critical value z. We learned how to find this. However, there is another distribution, which is the student t distribution, which gives sometimes better estimate of the mu, and it's sample dependent. That means I'll go over that distribution in a little bit. But if the population standard deviation is not given in the problem or is not known, then we use t sub alpha over 2, or sometimes n is less than 30 and the population is not normally distributed, then we use t. For make it easier, just know when sigma is known, use z, and the problem is going to state clearly. If sigma is unknown, use t. So, but the borderline for the population is 30. Sometimes n is less than 30 and the population is normally distributed. You can still use z, but that's going to be very rare. So, especially in our problems. So let's just go with sigma known and sigma unknown. So now I put this sub alpha over 2 b r is critical z value. T sub alpha over 2 is critical t value here, and n in both cases is the sample size. So now z is the normal distribution or the standard normal distribution. We have seen this a lot in the last chapters, so we use inverse norm with our calculators to find that. T is the student t distribution, which is completely different. However, if kind of explain that to you, t distribution, the graph is symmetric, exactly like the normal distribution. However, it depends on n. If n is small, then it's wider. If n is larger, then it's kind of steeper. And if n is greater than 30, then that approaches to normal distribution. So just know, same as standard normal distribution, right in the middle we have 0, we have positive values to the right and negative values to the left. And I put the note here for you. Depends on the sample size, it's symmetric and it has positive and negative values. Now let's just learn how to find the critical t values. We can use our calculators, however, TI-83 doesn't have the critical values for the student T distribution. So you need to know the table for this one also, and we're going to do both. First of all, confidence level is the same. It's going to be given to you. In this case, you need N because it depends on N. So what you need to do is to calculate the degrees of freedom. The formula for degrees of freedom is N minus 1. I will tell you what degrees of freedom are, but for now, just use the formula so you can read the table or you can use your calculator. So let's go over this example. It says find the critical T values for 90% confidence level, N equals to 20. So remember, N is 20. So if I calculate the degrees of freedom, 20 minus 1 is 19. 90% confidence level, we know already this area in the middle is 0.9, and the area in the tail is 1 minus 0.9 divided by 2, which is 0.05. So let's go read the table. I have the table. Do not worry of the areas in the two tails. If you know one tail, you are completely fine. So for the first example, I can write that here. So we found N to be 20. Degrees of freedom, we said it's 20 minus 1. Let me write it, 20 minus 1, which is 19. And area in the tail was alpha over 2 was 0.05. So we go area in one tail. Again, do not worry about that. 0.05, and degrees of freedom is 19, and you read that value. You can also do that. So it was 0.05 and 19. And let's see what we get. 1.792. So let's go up and check the answer. So if you look at that, you get negative. Again, it has positive and negative values. The table does not show negative values, but you know if it's to the left, then it's negative 1.729. And this one is, of course, positive. But when you use the critical value, you just use the positive one, 1.729 for the calculation. Calculator, you go to VARs, and VARs is right next to that, next to the clear sign. Inverse, well, we meant inverse second function VARs because we want distributions. And you pick number 4, inverse T. If you have a TI-84, I don't think 83 has it. Put area and degrees of freedom. Area in the tail was 0.05. Degrees of freedom is 19, and the calculator does give you the negative value. And of course, you can always use the positive one for your calculations. Let's do another example. 95% confidence level, N is 15. One more time, 95% confidence level is this area in the middle. The area in the tail is 1 minus 0.95 divided by 2, and that's 0.025. N is 15, so degrees of freedom are 14. So remember these numbers, 95%, the area in the tail is 0.025, or just remember 0.025 degrees of freedom, 14. Let's go to the table. Let me erase those. Let me put the new information. So we said 95%, so the area in the tail was 0.05, so alpha divided by 2 was 0.025. And the degrees of freedom was n minus 1, which was 15 minus 1 for our problem, and that was 14. One more time, forget the area in two tails. Just go 0.025 in one tail and degrees of freedom 14. And let's see what the intersection gives us. 2.145. So let's go check the answer. And we got it is negative 2.145 and 2.54145. And I put how to read the table here to area in one tail 0.025 degrees of freedom 14, and you get that number. That number on the left is negative and on the right is positive. Calculator, again, you go to distributions, number 4, inverse t, the area in the tail, degrees of freedom, and you get negative 2.145. Here I did another example for you. Please take a look at it and try to find it yourself and compare the answer. 99% confidence level, n equals to 12. I think by now you should be able to find that it's pretty straightforward. Examples of estimating mu. Let's say we have test scores. I have a sample, and in that sample I have 1, 2, 3, 4, 5, 6, 7 test scores. So n is 7. With 90% confidence level, estimate mu, the population mean. I notice this is a sample, so we don't have the population standard deviation, sigma. So the first thing I know, I'm going to have to use the t-distribution. So, and with S, you 99% or 95% of the time you use t. So just remember S and t are always together. What do we need in this case? We need the sample mean. We can calculate with that formula. We need the sample standard deviation. We can calculate by using this formula like we did in the beginning of the semester. Or if you want to use your calculator, put your x's. X's are the test scores in L1 and just use one var stats. So the mean is 73.14 and the standard deviation is S sub x in the cap, which is 25. Do not use sigma sub x. The calculator gives you sigma sub x, but it's a sample, so we take S sub x. So again, I introduce you to the interval. So the confidence interval is x bar minus c on one side and x bar plus c on the other side. So x bar minus, we are using t critical value. So t sub alpha over 2 times s over square root of n. So if you want to use your calculator for 90%, we said 90% the area in the tail, this is 90, and the area in the tail is 0.05. So you can go to inverse t 0.05. Degrees of freedom n was 7, so it's 7 minus 1, which is 6. So put the degrees of freedom, you get the critical value, negative 1.43, or you can use the table. It doesn't make any difference. Find the margin of error, t sub alpha over 2, we got it is 1.945. S was 25 from the calculator over square root of n, which is square root of 7 because we had 7 numbers in our data, and you get 18.36. So you do x bar, which was 73.14, the point estimate for mu minus e, 18.36, and x bar plus e, 18.36. So if you do that, you get 54.78, and the right side 91.5. So that's called the confidence interval. Now I put the steps for you to solve this problem. Find x and s For calculator is 1 bar stats. Find T sub alpha over 2. Use the table or calculator. Don't forget about the degrees of freedom. If you're using your calculator, it's inverse T. Type the area to the left of that value and the degrees of freedom. Use the formula, find the margin of error, and write the interval. I did put another example for you here. Please take a look at this example, write those down and try to do it yourself and see what you get, and you do have the complete solution with the steps. So now if you want to use your calculator just to find the interval, go to stat, highlight test, scroll down to number 8. You're going to see T interval. For input, you're going to see data and stats. If you have the mean and the standard deviation, highlight stats. And once you highlight stats, then you can put the mean, standard deviation, and n, and the calculator is going to calculate for you. If you want to directly do that by using the data, just, you know, those numbers are already in your L1, the test scores. And if not, enter them in L1 and use data, and you'll see the calculator will calculate the confidence interval for you. Another example, X bar is given 20, N is given 35, and the population standard deviation is 5. When you hear the population standard deviation, know that sigma is given. And we said when sigma is given, you use Z, and N is definitely greater than 30, so we can use Z. So in this case, we use Z because sigma is known. So the interval is going to be X bar minus Z, which is Z sub alpha over 2 times sigma over square root of N, and X bar plus Z sub alpha over 2 times sigma over square root of N. We have sigma and we have N. We have to find Z sub alpha over to 90%. If you remember, we said is 1.645. If you forgot, one more time, this area is 0.9. The area in the TED is 1 minus 0.9 divided by 2, which is 0.05. You can do inverse norm, 0.0501. You get negative 1.645. Take the positive one. 1.645 times 5, which was sigma divided by square root of N, which is square root of 35, and you get 1.39. 20 was the sample mean. So you do 20 minus 1.39, 20 plus 1.39, and this is your confidence interval. If you want to use your calculator, go to stat, one more time, highlight test, and number 7 is Z interval. And use that and put, of course you have to pick stats, put the givens, and the calculator will give you the confidence interval. Sample size. You can also calculate the sample size when you have E, given E for the population mean. So the formula, you take that formula, you square both sides, isolate N. So you don't have to know how to do the algebra because the formula will be given to you. N equals to Z sub alpha over 2 squared times sigma squared over E squared. And I did do an example here. 99% confidence level, E is given to be 5 and sigma is given to be 10. It says find N. 99% again, we know is 2.58 if you use your calculator. But remember, I said in the last lecture, this is a common Z value and they usually use 2.575. So you substitute, standard deviation 10 is given and E is given to be 5. It's not 5% to, so just leave it as 5. If you do that, you get 26.52. And one more time, if you watch my last videos, I said for sample size, you always take the next whole number, which is 27. Round up for the sample size all the time, even if it's 26.001, take 27. And here I saw that was a common question. So homework number 7, question number 6. I saw this one. I'll upload these notes for you so you can take a look at the solution. So I think that's good enough for this video lecture. I hope you're doing well, and I'll see you all soon. Have a good one.